Sure.
Okay, we'll do that now.
All right, welcome to our monthly program meeting for BayChi. On screen now, you'll see our topic for the evening, design and usability for robots in construction. Our speaker tonight will be Jackie Thompson of Dusty Robotics. Before we quite get there, a little bit about us. We are we are the local chapter for a couple of international organizations. Our parent organization is SIGCHI, a special interest group in human-computer interaction, and our grandparent organization is the Association for Computing Machinery. That's been around for quite a while, and we get to benefit from all that history. As a local chapter, we have memberships of, sort of the annual cost of joining BayChi is $20, and you get sort of access to all kinds of stuff. Now, this monthly program meeting is free to and open to the public, but we do have other activities, some of which you'll hear about coming up here. But in brief, we've got access and to the UX community that is BayChi. We have our monthly meetings here. We have a newsletter, as you see here on the slide. There's a job bank, birds of a feather meeting, which are just little special interest groups within our special interest group. And one of those is so our monthly speaker meetings are the second Tuesdays. On our fourth Tuesdays, we have a BOF that I host, and that is a meeting that is just about careers in HCI or Chi. Where are you? What is it you're doing? What are you up to? It's not much of a standing agenda there, but it's pretty much just there for sort of more socializing and networking. Let's see, it is only February, but as a warning, as an alert, we will be having elections for our officers coming up in June. So think about that as we go along. Other sort of general BayChi events that we have coming up. I mentioned the Continuing UX Life and Careers BOF, and that's that one on the fourth Tuesdays. But next week, we also have one that is about UX tools. And so I'll be talking a little bit about Figma and my use of it in my work these days, hosted also by Sammy, another BayChi volunteer. That's one of the things that we might remember as a touchstone. We are a volunteer-led organization, but coming up, we also have, for members in particular, for member priority, I guess, a field trip to the Air Route Traffic Control Center, where we'll get to see air traffic control folks doing their work in a very highly safety required environment. Lots of design concerns in an environment like that. That'll be fun to see in company with other BayChi folks. Information about that is on our website, and how to sign up for that is there as well. Coming up further on is a field trip to see, tonight's presentation is robots, but also we'll have another field trip to see more robots, and that is a surgical robot coming up, field trip in April there, and information should be on our website to look for that as well to sign up. I mentioned we are a volunteer-led organization, and some of the volunteering responsibilities and some of the volunteering or ways to help out as volunteers are up here. We've got social media and publicity responsibilities that could use more hands, video producers, people to help Steve update our website, which can use some updating. So if you've got ideas about a particular interest in UX that you'd like to foster a little community around, feel free to talk to us about forming your own little birds of a feather group, and that's something that we can help you set up as well. Further on, I mentioned about our elections. We've got 3 key elected positions that we'll be looking for chair, vice chair, which is me right now, and treasurer. And so that, and while these are elected positions for our steering committees, actually anyone who's interested can attend our steering committee meetings, which are the first Thursdays of each month. And it's there that we talk about things like, what do we want to do with our, what might we want to do with some of our programs, some of our other activities. Basically, that's the backstage for this sort of thing that you're seeing right now. So happy to have more volunteers join us, happy to have more people on our steering committees, and happy to have people interested in being elected officials, elected persons on our steering committee. So that's sort of the big introductions for the Bakehi stuff. And hopefully, especially if you are here for the first time, hold on. Okay, sorry, little stuff that should be on mute. If you're here for the first time, happy to have you. Do remember we are here every month. And let's see, for our speaker today, we have Jackie Thompson of Dusty Robotics, who has come from a background in or degrees in psychology and cognitive science. Woohoo! Here for the cognitive scientists. And she is here to talk about her work as a product designer at Dusty Robotics, where she has had responsibilities of user research and also design now to prevent bad things from getting in front of users, to save their days and make them better. All right, with that, I'm going to stop sharing and hand off the meeting to Jackie.
All right, thank you so much for the introduction, Edwin. I hope everyone can hear me. All right.
Thumbs up.
Okay. All right, then. Hi, my name is Jackie Thompson, and I am super excited to be here today and talking about my work as a user experience-driven product designer for the Dusty Robotics FieldPrinter. Designing a service robot that works on construction sites alongside the construction workers and all the building and everything that's going on presents many unique challenges that my team and I have worked hard to overcome. And I'm really excited to be talking about kind of our design accomplishments that we've gone over. So just to start with a little bit about who am I and why am I even here presenting today? So my background is in psychology and cognitive science. I'm really passionate about understanding how people interact with UIs and particularly robots, and implementing changes that help individuals' user experiences be as best as possible. At Dusty Robotics, I've been here for nearly 3 years. And being a product designer is only my latest role of several other things. I have been a field engineer. I was up at 6 a.m., went out to the job sites before the sun even came up. Not something super easy for me. I am not a morning person at all. But I was out there running our robot while it was still very early on in its stages of development. I've also worked as a QA engineer doing my best to break the robot in the office before it gets out onto construction sites so that nobody else has to see these broken features. I spent a lot of time creating test plans and going over mock scenarios, trying to do my best to bring as much as I could from construction sites into our little office. And in my current position, I am researching user needs and I'm redesigning all of the aspects of our user interface for our robot, because our system has a lot of room for improvement. We've come a long way since the time that I've been here. And I'm also working on designing our new features that will improve the overall experience that a user has, making our product faster, more reliable, and more intuitive to work with. So before I start talking about Dusty Robotics, I kind of want to give you guys a little bit of context. What's the field that we're working with? What is the environment like? Who are the operators who's using our product? So I'm going to do this, try to keep this interesting and brief. So one of the first things I want to talk about is computer-aided design. Technology isn't new in construction, but there have been several really big milestones that have brought construction into the modern age. And one of these things is moving from hand-drawn construction files to digital models. Prior to digital files, everything was drawn by hand on huge stacks of paper, the size of dining room tables. Huge teams of people had to work together to manually design and coordinate every aspect of how the building would fit together. The first attempt to change this and kind of use the technology that was available was with a program called Sketchwork. This was created in 1963, and it's attributed as the first computer-aided design program. At the time, it was not used very frequently. Several of these challenges were that technology still had a long way to go before it would be advanced enough to support the computational power needed for such complex files. Another large challenge with Sketchbook is that it just didn't have the support from the design community in order to push for the changes that needed to happen. And it wasn't until a program called AutoCAD made its debut on the market in 1982. Even then, it wasn't widely used yet. It wasn't until the late 80s and into the early 90s that things really turned around for AutoCAD. Partially because computers still lacked the processing power, but it also got the attention of many designers who pushed to get the features that they needed into this program. Some of the most important results from these digital files is that it increased design efficiency. The later iterations of the program included time-saving features such as conflict identification and resolution. This meant things like pipes were not going to be sticking out of the walls, or that electrical and water lines stayed far away from each other and didn't have any issues there. It also has very useful features such as collaborative modes that allowed designers from all over the world to edit the same model and work together on the same project without having to be in the same room. Today, it's one of the largest construction modeling softwares. It's used daily by every trade in construction, and they have both 2D and 3D modeling systems. So this information used to be on paper and then taken out to the field where construction workers had to be on their hands and knees, working hard to put this in the field. So in order for someone to build a building, you have to take the pieces of paper and diagram it out into the real world so that people knew how long the walls had to be, where the pipes had to go. And this required highly skilled people who spent years learning their trade to look closely at these blueprints and to manually draw this layout on the ground so other members of their company could come in with the materials and build everything based on these markings, lines and crosses usually. They would look closely at the construction files. They would use pre-marked points and tape measurers to match the model information to the real world. This process of laying out drywall specifically is called snapping lines. During this process, two workers will take a piece of string covered in blue or black or maybe some other colored chalk, and they would stretch the string out on the site, lift it up, and quite literally snap a line on the ground where the edge of a wall should be. This is a very hard process. There's a lot of time spending hunched over either a tablet or paper or kneeling on the ground with a ruler tape measure and a pencil to make these markings. So it's very hard on the body. It's an entire day process. You get up at 6 a.m., you're on the job site for the next 8 hours, crawling around trying to get all these marks on the ground as fast as possible so that somebody could come behind you and build a wall or dig a hole or drill through the ground to put a pipe in. And this requires very skilled workers. Only people with years of experience are allowed to perform layout and have the trust to be able to do this to the level of accuracy that's required for many building codes. Unfortunately, this also means that there is a lot of room for human error. Rulers and tape measures are not all built equally either. And if you're tired and overlook something, it's very likely that things could be shifted the wrong way or entirely missed. So you would assume that with all these challenges, someone would want to come along and make this process easier, build something so that people don't have to be out on the ground all day working on these. Unfortunately, there's a lot of challenges that have to be overcome before we can actually get very complex autonomous systems, robots onto construction sites. There are what we can consider limited successes. Single task construction robots are already out in the field working. These are things like automated drillers and excavators that can be used with the user from inside a room, or GPS-enabled driverless trucks, which also need to be monitored, but can be used to deliver goods around. Unfortunately, these things don't address everyday tasks that are on every construction site, and there's very limited in what they can do. They usually accomplish one task and that's it. They can't do anything else. Another obstacle to really getting robots on construction sites is the work culture that surrounds construction. Traditionally, all the labor is manual. People don't want their jobs taken by robots. They want to keep doing what they're doing. They have a very fixed mindset. It's very hard to convince someone who's been building perfectly put up walls for the past 50 years to try something new when the old method was working just fine. And things about like the accuracy in technology can be very hard to understand. And people find it hard to trust a system if they're not sure if it's going to be doing the right thing. And then when it comes to autonomous systems, there's even more obstacles that have to be overcome. High costs scare people away before they can even consider the benefits they may gain. And these potential benefits are kind of theoretical, and it's very hard to compare this with a clearly defined cost that they have to pay. Things like batteries are a concern on construction sites. They only have a limited lifetime, so they can only be used for so long. And not all job sites have active outlets to be charging batteries. And even then, if you have to wait for batteries to charge, it's going to restrict the amount of time that the robot can be used. A lot of things that are working on construction site need to be very complex. Both the software and the hardware are things that have to be able to react in the moment to what's going on. And this usually means hours, days, weeks of additional training. And during this time, these operators are not in the field building. They are just learning how to use this system that hopefully will improve things in the long run. Accuracy is also extremely crucial for building. It needs to meet health and safety codes. And adding technology can make it understand where the system tolerance is set. And entire portions of a building may be inaccurate before an area is caught. And this will result in a massive amount of rework that people are really worried about and want to avoid. Job sites already have strict regulations, and people also want to avoid adding more regulations. If you do have a robot roaming around a construction site, you'll need to follow all the preset regulations, and new ones are bound to be created to make up for any additional health or safety risks. And these safety risks are another one of the obstacles that we have to overcome in order to get a robot on a job site. They have to work in a very unpredictable environment, and the consequences of things going wrong can be quite severe. But speaking to all that, I'd like to introduce Dusty Robotics and the FieldPrinter that we have designed to overcome all of these obstacles and get actively working on construction job sites. Our robot automates the tasks of workers spending hours on their hands and knees with the chalk and Sharpies to draw a layout, and instead goes and draws this for you. So our system is made of several different parts. We have our autonomous robot that navigates through the job site, drawing the lines for construction. We have a very precise tracking system that guides the robot and holds us to our accuracy standards. And the most important feature in HCI is the tablet app, which is used to actually control and gives the operator feedback about the robot and everything that it's doing. So something that makes our robot a little bit different is that it's set up by an operator, but it prints autonomously. Once you've submitted a print job, the robot will go do its thing, and this gives operators the time to go and focus on other important tasks. They can double check where things are, they can spend their time working on all the other jobs that are very important to get a building complete. Our robot is also very versatile. It can be used by all trades. This means somebody from electrical background or plumbing or mechanical or walls are able to save time by doing all the layout at once. This means that new trades members don't need to come on the job site each week, do their portion of the job, have that built, and then have the next group come in and do their layout. Our robot also works in a wide range of climates. It could work on the hottest Texan day, or it can work in the very cold East Coast winters. Our robot is also very small. Unlike most robots, it can be packed onto one job site and only one person needs to bring it. I can even fit this in my little Honda Accord and have everything out on the job site the next day if I need it to. The last thing about our system is that it is very easy to learn. With only a couple hours of training, anybody, even union members, with no background in technology, are able to take our robot onto a construction site and start performing layout. So just to explain a little bit how our system works, our process begins with the digital design file of the building model, usually one of the AutoCAD models. This file is imported onto our tablet, and then the operator is ready to go to a construction site. We get on the construction sites at the same time as everybody else, usually about 6 or 7 a.m., ready to work for a super long lit day before the sun has even come up. The laser tracker and the robot are powered up, and while they're warming up, it's a good chance to kind of walk around the floor, look out for any hazards, clean up anything that's like too dirty to print on, which are the kind of the same conditions you have to go about when you're snapping lines, because, you know, chalk can't stick to dirt, neither can our ink. Once everything is powered up and once it's all ready to go, the tracker and the tablet are connected to the robot. Using the laser tracker, the robot is then able to autonomously drive throughout the construction site and print walls, print electrical markings, mechanical markings, plumbing markings. It's even able to quickly label walls and doors and room names, which gives workers extra information that they previously didn't have because it took too much time to get on the ground. So I want to talk a little bit about our average construction worker. Most construction workers have very limited technology exposure. Some of them may even still be using flip phones. Most people now do have smartphones and are familiar with basic tablets and can use the computer for things like Gmail and maybe streaming movies, but they probably don't do much more than that. Very few have ever used a robot or used a tablet to control said robot. And they have a very much a get the job done mentality. If our robot can't keep up with the work that they need to get done, they will not have a problem putting our system to the side and going back to stopping lines. But fortunately, we've had a really positive reaction to our system. Usually it's a see it, then we believe in it kind of situation. Once the members have had a chance to actually witness our robot for themselves, put the ink on the ground, they have a chance to use it and use the tablet. They're convinced that we actually can do what we say we're going to do, and that this is a valuable thing to have on the construction site. So moving on to the main interaction that people have with our robot is the tablet app. So this app is made up of several different parts. On the side over here is a control panel that gives the operator different options to interact with the robot, change some settings, and go through the different process to set up the robot. The portion of our app that takes up the most space is the canvas. This is where they can actually view the model of the building, and they can direct the robot to which area they want to print, or mark things so that they want the area to, if they want the robot to avoid those areas. And then we also have canvas tools. These are one of the most important interactions. They're used the entire time that the app is open, to move around the diagram, make any changes that need to be done last minute, and to start the print job. So this is super important that this is well designed. We want the controller to meet the needs of every operator who uses our system. These tablets and this app is actively used on a construction site. It could be really cold in the mornings and they get really hot in the middle of the day, so it has to survive a lot. Sometimes it's used before the sun is up in the dark. Other times it's used in the blazing sun and the screen can barely be seen. So we have to make sure we account for all of these things. We also have to account for the fact that if our tablet was to give any noises, it may be hard to hear because there might be somebody drilling in the corner next to you or sawing on something and you're not going to be able to hear anything. Our tablet is an extension of the robot also. While it can be left alone while the robot is printing, ultimately this is what the operator will need to come back to confirm that everything's been printed correctly or to clarify any confusion or things like that. This gives really crucial feedback about our robot process. But this design is pretty outdated. It's very limited in what we can do. And there's a lot of areas in which we want to address and improve this. So I'm really excited to be able to talk about some of the design changes that we've made to make this the best system possible. I'll be talking a little bit about our process to getting to these newest designs and trying to make a lovable product that anybody is happy to use and they don't have to struggle to understand what's going on. So the first thing that I'll be talking about has been our progressions through Canvas buttons. So as I previously stated, these buttons are used all the time. They're super important that they're accessible, that they're easy to click, because it means that this is going to tell you where the robot's going to print and is going to get the robot started. It's really important that these features are always accessible and everybody wants to be able to use them all the time. So some of the things that we need to consider when we're using this is that our tablet isn't held like a normal tablet. It's not in your face. You don't get to like lift it up every time. Most people hold it about 3 feet away from their body, all the way at an end of the strap. We also have to consider all the different environments that the tablet is used in. Sometimes it's nice and quiet indoors and you can see everything on the screen. Other times it's outside and it's very difficult to see things. And we also have to consider that everybody has to understand what these buttons do. So we've gone through many different iterations. Here I have some versions of our robot UI going all the way back to 2021. So this is a while after I started the company and I'd already been working for a bit, and we finally added the interactions that we needed to move around the screen. And as you can see, our first version are all along the top, kind of something similar that you would see on a desktop site, where you can easily get the mouse around and you have all your options. There's a lot of different buttons. You can see everything that you can possibly use all at once. But these icons are very small. They're also kind of difficult to tell what each icon is and what it's supposed to do. And it's very easy to overlook things that get added because you're kind of just like, oh, another new icon. I don't know what it does. I'm going to keep going and do the job the way that I did it yesterday. So this wasn't super useful at all. There are a lot of additional features here that most people didn't use and were just clutter on the screen. And this kind of brings us into the next design later on in 2021 in August, where we started adding some color. We tried to highlight only the important buttons that we needed and make them a little bit bigger so that even if you were wearing gloves on a construction site, you had a better chance of activating the button that you wanted to use. And these were the ones that I used very early on in my time at Dusty, before I was designing and when I wasn't actually a user. And so I saw firsthand the struggles to follow safety protocol and have my goggles and gloves on and still be able to click these buttons, or have to lift up the tablet and kind of squint and see like what I was clicking on. And then we've moved over into our newer design in May of 2022, where we have everything lined up on the side of the screen. This meant that you didn't have to awkwardly balance the tablet in one hand and click around the screen and hope you got everything. Everything was right on the right side along the edge, so you could just slide your hand up and down the tablet and click on whatever feature you need to be using. And so all of these transitions have led us into our final design. For us, it's very important that we have large buttons. Everybody needs to be able to see and be able to click on these buttons. Most operators don't have very small fingers either, so all of our buttons need to be large finger proof. The surface area means that everybody doesn't have to worry about precision or being too careful and is able to get right away to the button that they need to use. This also means that the tablet can be used naturally at the distance that people want to hold it, so they're not lifting it up and moving it around all the time either. The location comes from experience and from observing people on the job sites. Almost everybody held the tablet with their hands on the very edges, so we kept the buttons in a very easily to access place. And so now this also helped with the trying to hold it in one hand versus having it in two hands at all times. We also added text labels. These are most helpful for people using our system for the first time. After a day, they can just read and immediately use the feature that they want to. And this also helps people who maybe don't recognize what the icons mean, or maybe they've forgotten what they are. We also now have space for things like notification, just to give a little bit of extra feedback about things that are happening on the screen. Our features are also divided into two groups. Printing is slightly separated from the rest as it's more commonly used and has a slightly different function than the rest of the buttons, which are all kind of canvas interactions. So moving on to kind of another feature I want to talk about now is our canvas. And one of the most important things on our canvas are the different colors and our indicators that we use to talk about the health of the robot and the states of the different lines and the states of the robot. So for users, it's really important that this is easy to see in all different environments. Another thing is sometimes our app is used indoors on a laptop, and that does mean you have slightly different resolutions. There are some things that you can see there where you may not be able to see it on the tablet in the field. But also there are some limitations to what we can have as a computer app, and you have to handle the different types of zoom. And we also wanted to create consistency between everything that we were doing so that everybody understood what the colors mean, and we began to pair them with kind of like the information that they symbolized. And as always, our environment is a huge concern. I remember some job sites I would show up and it would be dark in the morning and I would think, oh, I'm on an indoor job site. I don't have to worry about the sun. This is going to be great. I'm going to be able to see everything all day. And then the next thing I know, the sun's coming up because there's no wall next to me to block the light. And so there's a weird glare coming across my screen and I'm not able to see half the things that I was looking at before. So we went through many different iterations of colors. And of course, because accessibility is important to us, we do testing for all types of color blindness ahead of time. And then every color palette that we came up with, we put into the field. We got feedback from people at our company who are using our robot out in the field every day. We take the robot out into the field ourselves to use it in all these different environments. And anything that previously was relying solely on colors was also able to have more icons and kind of some different shapes that were associated with it. So as you can see here, we've tried some different things. We tried grays, we tried going to blues and golds, hoping that they would show up well. And collecting as much feedback as we could so we could make the best choice. Our design solution led us to a very dark color palette. We want to kind of restrict what our users are able to do. We don't want them to accidentally hide information from themselves if they're not able to see it, and it can be very confusing. We also added symbols to everything that was previously reliant on color. Things like health and battery status now had a symbol as well that meant it was very clear what they meant. And each icon had different modes that people understood kind of what the state of the system was. And we also settled on kind of a final color scheme that we used across everything, so that if something was blue, you would always know that was printed. If something was red, that always meant some kind of danger or obstacle. We don't want the robot going near that. And it's associated with kind of like what people already associate red with. All right. One more thing that I want to talk about is kind of our print controls and the changes that we've gone through for that. This actually is one of the first UI systems that I used for Dusty Robotics in 2020. And at the time, our system was a mess. This is what the engineers designed. And if you follow this path, you have to go from the top to the bottom, back to the middle, and then kind of work your way left and right to the middle of the panel. And then assuming you were able to memorize this order, you would be able to print. But it was super easy to miss a step. If you did miss a step, any feedback was honestly complete gibberish to a user like me. I have no idea what the ROS code or what the messages were saying. And it made it very confusing to try to get the system up and working. And there were many times where I just had to give up and then start all over again. And that was a very time-consuming process where I would be halfway through and be like, okay, I can start printing. And then nothing. And I would sit and wait, and I'll be like, all right, step one, going all the way back to the beginning because I didn't know what else to do. So overall, I would not recommend this to anybody. 0 out of 10 stars from me. So it was very difficult. And even then you can see here how our canvas barely shows any information. We've got kind of a little box for a robot and everything else is just some lines. So part of the designs and the feedback that I gave was to actually utilize these bars that we had across the top. We divided up some information. We wanted to make it larger, a lot more presentable. So now on each page, you would start at the tab on the far left, working your way to the right, and each panel, you would start at the top and work your way to the bottom. Trying to get a very natural flow that people could follow. You didn't have to memorize what part of the screen you were supposed to be looking at or what button you had to push next. You can just go stepwise through each panel and get to the part of the robot where you can actually print and put ink on the ground. This led to a much more increase in intuitiveness. Anybody can follow this right away. And it also took advantage of kind of some of the features that we already had. We also moved the print button all the way across the screen from the little panel to the right-hand side, because once you set up a lot of the robot, you don't even need to come back and change the settings. You can just use the canvas and the print button to print back-to-back jobs without a problem. So this leads us to our kind of my final design solution for this. We now have vertical tabs along the left side that you can just follow down the page. It's very easy to access if you're holding the tablet on the far left side, as well as having a very simple vertical flow through each panel once you've opened it up. We've also moved to the point where you no longer need to view the robot settings the entire time while you're trying to focus on printing. You're able to do all your settings, and once you've gotten to the print button and you're starting your print job, you only see the information that's important to you. You only can see what the robot will be printing, and you can see actions that will directly affect the robot's current print job, and not everything that was already preset and that you can't change anymore. So the information that we're kind of focusing on is what is the amount of work that you've printed, how much time do you have left, and all the features that you need to look at to make sure that you kind of like know what's going on during the print job, but you're not distracted by information that's not useful. And so that's kind of all the features that I want to talk about for our system. unfortunately, we do still have so much more work to do. It's never ending. We have to do the same process for every single feature that was on all of our slides. So we're going to be continuing to study our construction workers, collaborating with our field team and with our engineers to increase the utility of our product. We're also going to do more studies, talking to get more feedback from the different clients using ours. We still have a lot to learn from people using our system on the East Coast. And we also want to work on improving our language to kind of match the colloquial construction terms so that anybody that already has experience on a construction site is able to understand what's going on. So here we have Dusty Robotics in my LinkedIn, where I will be continuing to post updates about our company and the different milestones we meet as our system improves. So with that, I want to thank Bake High so much for hosting me here, my company and my coworkers for supporting me and for helping me get to this point, and thank all of you for joining me on this talk today. So with that, I conclude my presentation. Thank you so much.
Thank you, Jackie. And I'm going to say, let me come back to, so, and would you want to ask any questions? I want to check on what's going on in the chat. There were a few things that we had earlier.
Yeah, I would be happy to answer any questions that people may have.
Well, Lisa had just a clarifying question about the early days of CAD. And what were you talking about? Sketchbook by Autodesk, or was there a different sketchbook before that?
Oh, there was a different sketchbook.
Was that an Evans and Sutherland thing, or who did that one? Do you remember?
I can.
Was it Xerox Park or?
I don't know.
Anyway, we should look at that. So Lisa, speak. You can speak. You can unmute.
Oh, okay, thank you. I love this presentation, by the way. I just really enjoyed this. My question is, what was the budget on the user testing?
Is the echo gone?
I didn't hear that. I'm sorry.
Well, when I first came to Dusty, I was an intern, and the size of our entire team was about 10 people. So there was no design personnel at all. There was really no, there wasn't a lot of consideration for the user at that point. And right now we are just beginning our work and kind of getting into actual user testing with our most recent designs. So honestly, at the moment, there's not really a budget set aside for user testing. We encourage everybody, including myself, to get into the field and kind of experience the robot as a user. And that's where we get a lot of feedback right now. But there's no really specified budget or anybody working specifically in research for our work.
May I just ask a follow-up on that? What was the cost in the end for the user testing that you did that gave you the results that you showed us? Even a estimate, I'd just like to know.
A lot of our user testing.
I missed that. I'm so
Sorry.
sorry.
Getting a little feed.
Oh, okay. I'm going to mute.
Thank you. Most of our user testing right now is done in-house with our own team. So they're already employees at the company. And we have had some interviews that we've gone out and collected. But I would say we have very limited resources right now to put towards that.
I'm hearing my own feedback now. Dilip asked, let me see what you said, Dilip. Is the robot controlled using Bluetooth or Wi-Fi or something else?
Our robot does have a Bluetooth connection, although that's not the main control. The main control is a wireless connection to the tablet. to interact with it. And there is also a little controller that's kind of like your average video game controller that I did not display. And that can also be used as kind of like an emergency tool to drive the robot around. It's not what's used to actually print and put the layout on the ground, though.
I'm looking again at the questions, but if other people have questions, you can join in this conversation. So do you use patterns of dots and dashes as well as solid colors?
Yeah, our system is capable of printing dots and dashes. Right now, we leave it up to the user to determine what they want these to mean. Something that we see pretty commonly is to use a solid line on the inner layers of the wall, and then to have some type of dash line on the outer layers to differentiate between different parts of the wall that someone may need to know in order to lay out. This is also really different than previous systems. Before, if you had a chalk line, you didn't really have the choice to put this kind of information on the ground. So right now we leave it very open-ended. We give people kind of a list they can choose from, and they're allowed to use those different combinations of dots and dashes and text to decide what they want the layout to look like.
Oh, thank you, Carl. So Carl Anderson added a Wikipedia link into the product Sketchpad, the earlier one, I believe, right? Let me just disappear for a second and look at that. A computer program written by Ivan Sutherland, 1963. Okay. And he got the Turing Award Prize for it in 1988. Good. That's what.
Yes, I believe that's
Good. Okay. Oops. Here we are. Thanks, Carl. I was about to hide that myself and I only have two hands. Now, Dilip, you want to ask your question about concrete versus other kinds of, uneven surfaces? Or did I just ask it?
Yeah, I can also ask. It's okay, thank you. So what I'm trying to understand based on the presentation, I saw the robot was walking on the concrete plain ground, right? I was curious because sometimes you have to, do marking on the plain ground without any concrete and maybe sometimes uneven surface as well. So does it help there as well?
We do print on different types of surfaces. Generally, when you're doing things like insulation for walls or pipes, you are printing or making ceiling marks, you're doing it on the concrete. We also print on wooden formwork, which for a lot of buildings is just wood laid out ahead of time that the concrete is poured onto. So while we have a limited amount of how rough the surface can be, we can print on many different types of ground.
Okay,
Cool.
thank you.
Did I miss a question from earlier? I know people have been saying, wow, it's cool. Looks like medical coding software. That was an earlier iteration. Lisa was commenting on that. That's all that I see in the chat. Who among the participants has further questions?
I don't have a question per se, but just a couple comments. Hey, Jackie. I just wanted to, well, first comment, the design change from kind of the second iterations to the third ones. All of a sudden those colors are popping and you've got contextual menus where you're right, all that extra information from those initial menus, if you're not using it, it's not on the screen, it's not in your way. Was super cool to see. I can see how now it seems Dusty's battle, I'm sure initially when you had 10 boots on the ground, as you were saying, and it was all about making the actual robot move around, print some stuff, right? But now it's about so much more than that. It's totally, you're on phase 2, it seems, where it's really about making a software solution that's compatible with such a wide range of people who are already very experienced in what they do, and they have exactly tried and true methods. If snapping chalk lines on the ground for the last 50 years has worked, then even if you have a better solution like this robot, that may be sure it can do it, right? That's not worth anything if the people behind the tablet can't figure out how to use that UI. So personally, just as your friend, it was super interesting hearing. I've heard, little bits, tidbits, and snippets, from just when I get to see you in person about, how are things at Dusty and all that. But it's cool to actually now I really understand kind of what you're up to, and it seems like you're in a very valuable position if you're contributing to this next step. Which, yeah, it just seems like it's something Dusty needs to address. And it looks like, from what I saw, I mean, I feel like I could click around in buttons and that, and I have no idea about CAD or software or building anything other than I'm in biotech, so I'm in a completely unrelated field, but it's very cool. Man, if Fairsight ever needs to build a new campus, I'll tell him to go over to Dusty's, and we can probably press some buttons on the robot ourselves by that time, and get drawings on the floor. So anyway, that's what I had to say.
Thanks, Andrew.
And you didn't have to pay him for that, I understand, right?
I didn't even know he was coming until about like half an hour before the meeting.
Great story. I like that. Great story. Okay. Anybody else besides classmates of Jackie's want to speak up? Who hasn't spoken before? Edwin, do you have anything more to say?
I just really appreciated the presentation. Seeing the robot in action was kind of fun as well. Of course, video is always a plus. Yeah, seeing the rearrangement of the necessary actions to get that robot, to get the information into the robot, to get to the print job, that was fantastic.
I have to chime in and say, it's reminiscent of a project I worked on where I was a complete outsider, but they had an existing sequence of panel of controls and menus that they were working with. It was not a CAD program. It had a completely different function. But when I presented the findings of the user research to the team and the executives, I said, just watch how I have to move, how people are becoming accustomed to moving. Your first move is on the first menu and it drops you into the third menu. And then you make a selection there and it drops you into the second menu. And by the time you get to the sixth menu, you have no idea where you are. Right? So I feel like you've brought a little shared cultural logic. That is top left down to the bottom right. Yes, this is the way we read. This is how we think. But, people aren't conscious of that if they don't have a little self-reflection about the other kinds of technologies that we use, like writing,
Very true. Thank you.
Yeah, no, but it's a wonderful story to tell about how you took the confusing ordering of things and then brought a little bit of order to that. Yeah. Thank you so much. Well, let me just close with the people we have remaining to let you know that next month on March the 10th, I believe, is going to be a BayChi meeting, Tuesday, second Tuesday of the month. And we're going to have Jared Spool. And I haven't been able to wrestle from him the title of his talk. Some of you may know him. He's the founder of an organization called User Interface Engineering. And more recently, he's also been the co-founder of an educational program for UX designers and researchers called Center. I think it's spelled in the British or Canadian way first and the American way second. Anyway, a little silly name for a program you can find out about, and I'm sure he'll tell us about. And he's been doing a lot of education of people in that formal setting for degrees with accreditation, and then informal learning as well. And then the person who's going to speak on the second Tuesday in April, and I didn't pull up my calendar, so I won't tell you what the date is and be wrong, is Don Norman, whom some of you must have heard of in cognitive, if you came and you're interested in cognitive science, professor emeritus twice at UCSD. And he's got a new book coming out. And so he asked us if he could do one of the early talks about that new book in April. So we'll have that for you. And May and June, I think, are still being negotiated. So can't tell you more than that. But Jackie, we're thrilled that you were able to be with us on Valentine's Day. And we hope to see you around Bake High more often. And thanks
Thank
to
you.
everybody. And we'll see you next month.